So these are part 1 of notes for 18.1 and 18.2. These two sections cover kind of the same thing, but it is kind of a big section and there's a lot to talk about, so I'm going to split it up into 2 parts for you guys. The first part here is just an introduction to the trig ratios. And so if you read that top statement there, if you only know the measure of one side of a right triangle, so remember we have to be working with right triangles here, and we know the measure of one of the angles besides the right angle, then you can use trig ratios to find the length of the missing side. So we have these trig ratios here off the left-hand side called sine, cosine, and tangent. Sine, cosine, and tangent. And these are the abbreviations you will see for them. SIN, COS, and TAN. Sine, cosine, and tangent. It is not sin, cos, and tan. Okay, please use the actual names. Okay, sine, cosine, and tangent. And along with that, okay, we also have a new variable here, and that's the Greek letter theta. Okay, this really just represents an angle. It's just like an x. It focuses just like an x would, just a normal variable. However, this one specifically is used for angles, and it just kind of helps us differentiate between side lengths and angles, so we use this one a lot with the angle. Okay, that's called a theta. It's a little zero looking thing with a line in the middle of it. Okay, as long as it looks something like that, it's fine. It doesn't have to be perfect. Okay, but you guys get the idea there. And so with our triangles, the big thing is trying to figure out, 1, where our right angle is, and 2, what angle are we talking about? What angle is going to be our theta? So in this case, they've labeled the bottom right angle here, the theta, and so we need to be able to label 3 different sides. The first one is the opposite side, which is the one across from that angle. Okay, so that's called your opposite side. It's the one all the way across from it. Then you have your adjacent side, which is the one that's right next to it. And then lastly, we have our hypotenuse, which you know is across from the right angle. Okay, so the hypotenuse is the longest side across from the 90 degrees. Okay, so if you can label those 3 sides correctly, a lot of your work is done. Okay, that's kind of the nice thing about this, is once you get those set up, the rest of it's pretty straightforward from there. So again, here's another example. We have our right angle down here in this corner. We notice our theta is up in the top. And so if we look, our hypotenuse is right across from the 90 degrees. And then across from our angle is the opposite side. And then right next to it is the adjacent side. Okay, so it all just kind of depends on which angle we're talking about. And you notice that as my theta changed, right, it went from the bottom right corner here to the top left corner on this one. As my angle changes, so do my sides, right? This was the opposite side here because it was across from this theta, but now my opposite side is down here because now it's across from this angle. Okay, so as your direction changes, as your angle changes, so do your sides. Okay, so you have to be careful which angles we're working with, and that will kind of help you know there. So for these next 2, I'm going to say go ahead and try this on your own really quickly. Label each side opposite, adjacent, or hypotenuse given each angle theta. So I'm going to have you pause this for a second, and then I'll show you the answers to see if you got it right. So on this triangle, you notice here's theta, here's your 90 degree angle. So across from that is your hypotenuse. Across from your theta is going to be your opposite side, and right next to it is going to be your adjacent side. Pretty straightforward. And on the next one, again, we've got theta, we've got our 90 degrees, so across from that is your hypotenuse. Across from theta is your opposite side, and right next to it is your adjacent side. Now, these trig ratios have are ratios, right? They're fractions. And so sine of an angle, the sine of an angle is the opposite side. Whoops, sorry. Let me rewrite that in a different color. Is the opposite side divided by the hypotenuse cosine is the adjacent side over the hypotenuse, and the tangent of theta is the opposite side over the adjacent. And so to help you remember these, okay, you need to remember those three right here in the middle of the page. That's kind of your big idea there. Is this acronym SOHCAHTOA. SOHCAHTOA. And so SOH, CAH, and TOA. So helps you remember that S equals O over H. Ka reminds you that cosine is adjacent over hypotenuse. And TOA, tangent equals opposite over adjacent. Okay, so it's a little mnemonic device, a little acronym there to kind of help you remember those. SOHCAHTOA. Okay, so if you need to write that a couple of times, I recommend it. If it helps you to write it this way with the equal signs and the fractions with the letters, that's totally fine. But just maybe that'll, I think, help you guys remember this a little easier. And then notice that your ratios are always going to follow this pattern. You're always going to have your trig ratio, whether that's sine, cosine, or tangent. You're going to have some angle, which typically we write as a theta, equals your side length over a side length. So it's either going to be your opposite side, your adjacent side, your hypotenuse, depending on what you need. Okay, so that's kind of an intro to those ratios there. On the next page, we're going to practice using those. So find the cosine, sine, cosine, and tangent of each specified angle. Write each ratio as a simplified fraction and as a decimal rounded to the nearest hundredth. So example 1, part A, says use angle D as your angle. So for this one, we're going to let angle D be theta. And so if that's the case, we have our 90-degree angle here, which means that 17 is going to be our hypotenuse. And that 8 is going to be our opposite, and 15 is going to be our adjacent. So if we set those up, sine of D, sine, something I would recommend doing at the top of every page. So, SOHCAHTOA, and I'm going to rewrite this one because that looked kind of bad. That way that is just kind of there in front of your face in case you forget. So sine is opposite over hypotenuse. So if we look at our triangle, opposite was 8, hypotenuse was 17. And can we reduce that fraction anymore? In this case, no, we can't. So we're going to move on to cosine of D. Cosine of D is adjacent over hypotenuse, which is going to be 15 over 17. And again, we can't reduce that any farther. And then tangent is opposite over adjacent, TOA, OA. And that's going to be 8 over 15. Then part B says, now let's focus on angle F. Right, so now we're working with angle F. And so if we look at angle F, for angle F, if this is our theta, Again, our 90-degree angle hasn't changed, so our hypotenuse is still the hypotenuse. But this time, our opposite is the 15 side, and the 8 is our adjacent side. Okay, so on this one we're going to be using the red letters because our angle has changed now. And so the sine of f is still opposite over hypotenuse, but in this case my opposite is now 15. My hypotenuse is 17. Cosine of f is still adjacent over hypotenuse, which is going to be 8 over 17. And then tangent of f is still opposite over adjacent, which is going to be 15 over 8. So that is A and B, and the directions also say a decimal rounded to the nearest hundredth. So now we're going to go back and do that, since I forgot that earlier. I apologize. So decimal rounded to the nearest hundredth. 100 has 2 zeros, so 2 decimal places. So if we use a calculator, 8 divided by 17 is 0.47. 15 over 17, 0.88. 8 over 15 is 0.53. And what you should have noticed when looking at these now in hindsight is that sine of D and cosine of f are the exact same fraction, and that cosine of D and sine of f are the exact same. So thankfully we've already done that work. So that one was 0.88. This one was 0.47. And then something to point out, that tangent of D and tangent of f are reciprocals of one another. They're the fraction flipped over. So if we find this decimal, 15 divided by 8 is 1.88. Okay. So that's kind of how you do example 1. Again, the biggest thing is trying to figure out what your angle is that you're working with, whether that's D or F, and then if that's the angle, what are your 3 sides? Which one's your opposite, which one's your adjacent, which one's your hypotenuse, and then set up your ratios from there, and then solve. And at this point, I think it helps to write this every time. Some of you might get to the point where you know it's O over H and you can jump straight to 8 over 17. But for many of you, it might help to continue to write that, especially as you're still learning it. So that way it gets more and more stuck in your head. You memorize it a little better and a little easier. So I'm going to have you go ahead and take a moment and try example 2. I'm going to fill that out in just a moment, but go ahead and pause the video and see if you can fill out example 2. So sine of A is going to be opposite over hypotenuse, which is going to be 18 over 30, which if we reduce that fraction is 3 over 5, which as a decimal is 0.6. Cosine of A is adjacent over hypotenuse. So we have 24 over 30, which reduces to 4 over 5, or 0.8. And tangent is opposite over adjacent, which is 18 over 24, which is 3 over 4, or 0.75. Sine of b, now working with b, is going to be opposite over hypotenuse, which is 24 over 30. Again, 4 over 5, which is 0.8. Cosine of b is adjacent over hypotenuse, which is 18 over 30, which is 3 over 5, or 0.6. And then tangent of b, opposite over adjacent, is 24 over 18, which is 4 over 3, or 1.33. And that's it. Okay, that's using your trig ratios. And so these reflection questions down here at the bottom, go ahead and answer those. Take a moment to read through those and put down an answer for them. We'll kind of talk about them in class and see what you guys notice. We already talked about the first one a little bit, as well as the second one. So just write a short sentence. Doesn't have to be super long, but just kind of write something brief about what you noticed there. Example 3, in a right triangle, PQR with PR equal to 5, QR equal to 3, and the measure of angle Q is 90. What are the values of sine, cosine, sine of P, cosine of P, and tangent of P? So we have a right triangle here. We know that Q is our right angle, so we know that we have P and R. It says PR is 5, QR is 3. And so in this case, we can use the Pythagorean theorem to find out what PQ is. So we have a squared plus b squared equals c squared. So a squared plus 3 squared equals 5 squared. A squared plus 9 equals 25. A squared equals 16. We're going to square root both sides. So a must be 4. So now that we know that, we can set up our trig ratios, and we're wanting to know angle P. So sine of P, cosine of P, and tangent of P. So if P is our theta, opposite over hypotenuse is going to be 3 over 5. Cosine is going to be adjacent over hypotenuse, which is going to be 4 over 5. And tangent is going to be opposite over adjacent, which is 3 over 4. And that's it. Okay, so thankfully, since we're still working with right triangles, we can use the Pythagorean theorem, and we can combine that with our trig. Example 4, if cosine of x, angle x, so x is our theta, is 5 over 13, and sine of angle x is 12 over 13, find the tangent. And so think about this for a moment. What does cosine represent? Well, what two sides does it use? It uses adjacent and hypotenuse. So that means that 5 is my adjacent side, and 13 must be my hypotenuse. So 5 and 13. And you'll notice I wrote the wrong side there. It should go here. And sine is opposite over hypotenuse. So 12 is my opposite, 13 is my hypotenuse. 13 we've already got there. So on my opposite side, we're going to write a 12. And so if that's what our triangle looks like, then the tangent of angle x is going to equal opposite over adjacent, which for us, opposite adjacent is going to be 12 over 5. And that's it. Okay. These discussion questions, go ahead and read these and think about those. I'll kind of ask you about them in class. Complementary angles, don't worry about this section. This was a section we used to do and I forgot to take it out, so don't worry about that. You can read through it if you really want to. Essentially, it kind of talks about the fact that the cosine of one angle is the same as the sine of the other angle, which is something we noticed on the other page. So to find missing side lengths, okay, we can use our trig ratios. So these 6 steps are going to explain those. You can read through those if you'd like. Number 1, here is our 90-degree angle. So across from that must be our hypotenuse. And here's our 65 degrees. So across from that is the opposite side. And so what 2 sides do we have at this point? In this case, we have O and H. And so we want to think back, which of my 3 trig ratios, sine, cosine, or tangent, use O and H? So think back to SOHCAHTOA. SOHCAHTOA. Which one uses O and H? In this case, that's going to be sine. Okay, so we're going to use sine here because that's the 2 sides that were given to us. So let your problem help you dictate which one to use. So in this case, we're going to have sine of theta equals opposite over hypotenuse. Now, theta represents my angle. And what is our angle in this case? If we look at our triangle, we're using the 65-degree angle. Our opposite side is going to be x. Our hypotenuse is going to be 14. So now we need to get the x by itself. So we're going to multiply both sides by 14. So that cancels there. And so x equals 14 times sine of 65 degrees. And here is where your calculator comes in handy. If you take out a calculator, like the ones we have in class, go ahead and type it exactly as it says, 14 times sine. You'll notice right in the middle of your calculator, kind of right above the 7 key, you'll see the SIN button, sine. Let's go ahead and click that. Then type in 65 and close your parentheses. And you get your answer of 12.688. And does it give us any measurements to use, any decimal places? No, it doesn't. So you can put 12.688, you could put 12.7. And do we have any units? Looking at our triangle, no we don't. So either of those would be acceptable. Okay, but once you get to this step, it's really nice because you just plug that in a calculator. You just type it in, 14 times sine 65, and then enter. If you're trying to use your phone on this, it gets a little trickier. So I'll show you guys how to do that with your phone because you kind of have to do it in a different order. But if you're using the calculators in class, which I highly recommend you do since those are the calculators you'll use on your quiz and on your test, start getting used to that because they're much easier to type in that way. Your phone's a little weird, and I'll show you guys that in class. So number 2, I'll give you guys one more example here. I know this is a long video, I apologize. But again, we have an angle here. And so across from our 90-degree angle is our hypotenuse. Across from this angle is our opposite side. And it wants us to find the measure of SU. So if we look here, that's this one right there, which according to our angle would be our adjacent side. So which 2 values do we actually know? Well, we know The opposite side is 87. I don't know what the hypotenuse is, but I do know that the adjacent is x. So the two sides that we have are going to be your opposite and your adjacent. Opposite and adjacent. So which of our three ratios uses O and A? You guessed it, tangent. So we're going to do that work over here. So tangent of theta equals O over A. So tangent of our angle, which is 54, equals opposite 87 over x. Now, this is the one that gets a little tricky when your x is in the denominator. Okay, here's how you're gonna have to do this. You're gonna multiply both sides by x because I have to get it out of the denominator. So I've got to move that over to this side. So you're gonna have x times the tangent of 54 equals 87. And then to get x all by itself, I now just divide by tangent of 54. I'm going to divide by that whole thing, because that whole thing is one number. So by doing that, it gets rid of that on the left-hand side, and all we're left with is x. And then this is now what we type in our calculator. 87 divided by tangent of 54. So in your calculator, go ahead and type in 87 divided by tangent, which is kind of right above the 9 key, right in the middle, divided by tangent of 54, close your parentheses, equals, and so your x turns out to be 63.209, which you could just round to 63.2. Okay, so that's kind of the tricky one there. When your x is on the denominator, you have to do that extra step by moving it over first and then dividing by your trig ratio. Okay, so that's if your x ends up on the bottom. If it's on the top, like the first example, it's really easy. You just multiply the bottom number over to the other side, and then you're pretty much done. Okay, so there are a couple more examples here on the bottom of this page, number 3. And then also, if you still have any questions there, you can simply ask me in class. On the next page, there are some examples here. So we're going to talk about a couple of those in class, but go ahead and try at least number 3 and then maybe number 4. And then